Welcome students. Today we are going to start the new topic in our syllabus, that is quadratic functions. Before starting this new topic, let us revise what we have studied so far. We started with some simple geometric objects like points and lines. After studying points and lines geometrically, we plotted them on coordinate plane and seen how to derive the algebraic equation of a geometric line. When we have seen the algebraic equation of a geometric line, we got a form of the form y is equal to mx plus c. Y is equal to mx plus c is also known as linear function that we have seen in last few lectures. And if you recollect it from the first week where you have studied functions, this is fx is equal to mx plus c is a linear function. Now we want to enhance our knowledge further and add one more intrication or one more complexity in this particular function, and that is why we are studying quadratic function. Here we will take an approach where we will first state the algebraic form and then derive its geometric properties, as opposed to what we did in straight lines. So let us start with quadratic functions. The first question is, how will I define quadratic functions? The answer to this question is given in this slide. So a quadratic function is described by an equation of the form fx is equal to ax square plus bx plus c, where a is not equal to 0. Where a is not equal to 0 is a crucial condition. Why? If a is equal to 0, it simply reduces to a linear function. Let us talk about the name quadratic function. The name quadratic function is derived from one foreign language where the quadratum, the actual word quadratum means square and quadratic means related to square. So a quadratic function is a function that is related to square of the variable. As can be seen from the definition, it has a term containing ax square. So if a is equal to 0, then it doesn't have a term containing square, so it no longer remains a quadratic function and it is a linear function which is equivalent to a straight line as a geometric object. So we will put a condition that a is not equal to 0. That means we are studying a quadratic equation. The next question is how to plot a graph of this function. So this equation is actually composed of three terms. Let us describe them one by one. That is ax square. This term is a quadratic term. As I mentioned earlier, when a is equal to 0, the term bx plus c survives, and that term bx is a linear term. And finally, if you put x to be equal to 0, only term that survives is c. So that is nothing but a constant term. So a quadratic equation can be split into three parts. If ax square is not there, then I know how to handle this term on a coordinate plane. It just simply represents an equation of a non-vertical line. So I know how to handle these terms. So what if the ax square term remains? That is, a is not equal to 0. We can graph this particular function, and graph of any quadratic function will be called as parabola. Graph of any quadratic function will be known as parabola. So what are the important features of parabola? In order to that, we first need to plot the parabola. So what is the best way to do it? We have already seen, to graph any function, what we need to do is we need to take the value of x, put it in the formula fx and evaluate it and get the values of y. So consider all ordered pairs and plot them on the coordinate plane so that they satisfy this function. This is the best way to handle it. For example, let us take for example when b is 0 and c is 0 and a is equal to 1. Let us take that particular function, that is y is equal to x square. In that case, what I will do is I will put x is equal to 0. I will get back 0. So I will plot a point 0 comma 0. I will take x is equal to 1. I will get 1 minus 1 1, and then if I take 2, then I will get 4, and if I take minus 2, again I will get 4. So y is equal to x square can be easily plotted by joining these points smoothly. This is the curve y is equal to x square. This is how we plot our quadratic function. Okay. Let us take one example. Let us say I want to graph a function y fx is equal to x square plus 2x plus 1. How will I graph this function? In 3 steps. First, I will generate a table of ordered pairs satisfying the given function. Second, I will plot those points on the coordinate plane. Once I plot those points on the coordinate plane, I will connect a smooth curve joining the 2 points. This is the recipe for drawing a function. Let us draw it here. For that, I have computed some points. You can verify by yourself. If you put the value of x to be equal to minus 2, you will get minus 2 square, which is 4, plus 2 times minus 2, which is minus 4. So 4 minus 4 gets cancelled and you will get 1. You take the value to be minus 1, you will get 1 for x square. You will get minus 2 and 1 in the constant term. So together they will cancel and you will get a 0. Similarly, you can compute for 0 it is 1, for 1 it is 4. Now our job is to consider a coordinate plane and plot these points. So I have plotted these points. So these points are plotted, and now I need to draw a graph which is connecting all these points. Now here you remember I have plotted these 3 points. How will I know the shape of this graph in this zone? That is a major question that you can ask. But this parabola is somewhat symmetric. In a sense, suppose I take this point. What is the point here? The point is 1 comma 4. Now if I consider this point, which is minus 1, where it takes the value 0, and consider the point 1, it is 2 units apart. So somewhere in this where minus 3 will come, which is 2 units apart from minus 1, the value of the parabola will be again 4. I will keep the cursor here. See, so there is some kind of symmetry underlying this particular function. We need to understand that symmetry in a better way. So what essentially is happening is, if I consider this point, which is the bottom of the curve, and if I draw a straight line, which is the line x is equal to minus 1, then if you look at all these points, for every point there is a similar point on y-axis at the same distance from this particular point. This also can be called as a symmetry of a parabola. We will study this later in the next slide. So right now our job is to graph a function which we have plotted, and let us explore further properties of this parabola, like this symmetry. What is the meaning of this symmetry and all those things? So there are few important observations. If you consider equation of y is equal to ax square plus bx plus c, this all parabolas, I have shown you 2 parabolas, y is equal to x square plus 2x plus 1. Both parabolas have axis of symmetry. Inevitably, all parabolas will have an axis of symmetry. That is, what is the axis of symmetry? Let us go to the previous slide and see. The axis of symmetry over here, as I mentioned, was x is equal to minus 1. If I take this graph paper and fold along x is equal to minus 1, then the curves that we have plotted here must exactly match each other. That gives us a recipe to draw a parabola. So all parabolas will have axis of symmetry. That is, if you take a graph paper containing the parabola and if you fold it along the axis of symmetry, the portions of the parabola on both sides will exactly match with each other. This is the beauty of a parabola. So now if I know how the parabola behaves on one side, I know how the parabola behaves on the other side of the axis of symmetry. It's a pure reflection of whatever is happening on one side. Then the point, this axis of symmetry, as we have seen in the previous graph, the point at which this axis of symmetry meets parabola, we will call that point as a vertex of the parabola. This is again a nomenclature. We will call that point as a vertex of the parabola, and the point at which the x, if you put x value to be 0, then the point at which the y coordinate is taken is called the value c, or you can simply refer to the equation ax square plus bx plus c. Put x is equal to 0, that will be the y intercept, which will be given by c. These 3 points play crucial role in graphing the parabola. How? Let us do it one by one. Let us say our quadratic function is ax square plus bx plus c, where a is not equal to 0. You can easily figure out that the y-intercept of this point by putting the value 0 is c. Now I want to know the axis of symmetry. This plays a crucial role. So I will derive the expression for axis of symmetry later, but right now you memorize this equation as x is equal to minus b by 2a, as this needs some algebraic skills which we don't have right now. So I will derive it later, but right now you understand that x is equal to minus b by 2a. Remember, the equation of the quadratic function is given by ax square plus bx plus c, and c will not play any role in this, and b and a will play a role. So it is minus b by 2a is the axis of symmetry, and where the graph meets this parabola, it is called vertex. So the x coordinate of the vertex is minus b by 2a, obviously, because the axis of symmetry has x is equal to minus b by 2a. So the x coordinate of the vertex is minus b by 2a. Let us see how this knowledge helps us in understanding how to draw a parabola. So there are 3 steps in drawing the parabola. First, you need to generate a table of values, but if you generate a table of values only on one side and you do not have a table of values on vertex, then you may not be able to draw the parabola appropriately. That is why the knowledge of these facts is important. So let us see how to draw a parabola by example. Fx is equal to x square plus 8x plus 9. I want to graph this function. So I will reiterate on previous points. So what is a y-intercept? Y-intercept is 9, because if you put x is equal to 0, the y-intercept is 9. Next, I want to know the equation for axis of symmetry. So in this case, what is b? B is 8, a is 1. So minus b by 2a is minus 8 by 2, which will give me axis of symmetry to be equal to x is equal to minus 4. Y-intercept is 9, axis of symmetry is x is equal to minus 4. So I can evaluate the coordinate, that is minus 4 comma minus 7 will be the vertex. How this minus 7 comes? You just substitute minus 4 over here in this expression, you will get the value to be equal to minus 7. So now with these 3 terms, how will I draw the function? So now I need to I know that around vertex I need to find the points. So based on this I will draw a table. So around minus 4 I have simply taken 3 points. 4th point is already with me. 0 comma 9 is the 4th point. Okay. So around the point minus 4 I have taken the values. So minus 3 fetches the value of minus 6 when you substitute in the function. Minus 4 minus 7 already known, and minus 5 minus 6. So I have 3 points and the point 0 comma 9. So I will plot these points on a graph paper. Take a graph paper, plot the axis of symmetry, because around this the curve should be symmetric. Take these 3 points. These 3 points are here, and I know 0 comma 9 is another point, right? So it should be somewhere here. 0, 9. Now let us plot a graph. Correct? So now we have plotted a graph with much ease. Because of the knowledge of axis of symmetry, I know where the point, the point where the minimum has occurred, or the vertex point is. That is the beauty of axis of symmetry. So this is how you will be able to plot. You will be able to plot any function, any quadratic function given to you. This is about the graphing of a function. Let us try to see, is this the only shape that is possible? That is the upward shape. Let us try to figure out whether is this a quadratic function first of all. Minus x square plus 1. The answer is yes. A is equal to minus 1, B is equal to 0 and C is equal to 1. Now in this case, let us try to figure out the three summaries. That is, what will be the y-intercept for this? Y-intercept will be 1. What will be the axis of symmetry for this? Because B is 0, it doesn't matter what is the value of A, it will be 0. So x is equal to 0 is the axis of symmetry. That is, y-axis is the axis of symmetry for this particular function. And the vertex is 0, 1. In this case, we are not really getting much information, because what this is saying is 0, 1 is the y-intercept. That is 0, 1 is the coordinate. Axis of symmetry is 0. That means 0, 1 is the vertex as well. Right? But still this information will suffice, because I know I have to find the points around 0. So let us figure out the points around 0. Minus 1, 0 and 1. These are the 3 points. Why their y coordinates respectively are 0, 1, 0. Right? Now you see there is a change. Earlier we were only dealing with positive side of y-axis, or the y-axis where the curve is opening up. Here the curve is opening down. For example, if I plot an axis of symmetry over here, which is y-axis, and if I plot these 3 points look like this. That means the curve will go downward. So the curve is opening down. Why this has happened? In earlier examples, if you look at it closely, then the general form of this expression, ax square plus bx plus c, in all of them a was equal to 1, and in this particular expression a is equal to minus 1. Therefore the curve is actually opening down instead of opening up. This point needs to be noted. So let us note this point and figure out what happens when this a is greater than 0 or a is less than 0. So that leads us to the next question, that is maximum and minimum values. So the y coordinate of the vertex of a given quadratic function is minimum or maximum value attained by the function. Do you all agree with this? We have seen 3 or 4 graphs of the functions. First we have seen y is equal to x square, where it goes to bottom and 0 is the minimum value. Then we have seen y is equal to x square plus 2x plus 1, which again gave us 0 value. Then finally we have seen the third graph that we have seen, the last graph, that is minus x square plus 1. Because the value of a was negative, it was going downward, and that will give me the maximum value, and all the values are below that value. So the y coordinate of the vertex of a given quadratic function gives us the minimum or maximum value attained by the quadratic function. In particular, given any graph, given any function fx is equal to ax square plus bx plus c, where a is not equal to 0, the graph of this quadratic function, if a is greater than 0, will open upwards and will have a minimum value. If a is less than 0, the graph will open downwards and will have the maximum value. And there will be either maximum or minimum values, not both. This is the beauty of the quadratic function. Another thing that you can see is the range of the quadratic function. if you relate to your week 1 background where you are discussing about the domain codomain range, so the range of this quadratic function will be, so let us say a is greater than 0, then it attains the minimum value, then it will be the minimum value and all of the real line that is above the minimum value. So I can and if a is less than 0, then it will be the maximum value and entire real line which is below that particular thing. I can denote this using the set theoretic notation as it is set of real numbers r intersected with set of all fx, that is y values, such that fx is greater than or equal to fmin when a is greater than 0, or if a is less than 0, it is set of real numbers intersected with fx such that fx is less than or equal to the maximum value that f has achieved. So let us try to visualize this. For example, if a is greater than 0, your graph looks like this. So in particular, the range of the value, range of y values is from this point to upward. So this is the entire real line above this value. Similarly, if a is less than 0, the range of the values that is taken by this function is this. If you relate this to domain codomain terminology, what is the domain of this quadratic function? It is entire real line, and range is restricted to some subset of real line. So we will try to improve upon this concept using this example.